Hello class, for today's lesson is about comparing and evaluating square roots and cube roots. And here are the learning targets. I can compare square roots and cube roots in different situations, and I can decide which value is greater or smaller and explain my reasoning. In order for us to compare correctly, we need to determine which of two values is greater, smaller, or equal, and evaluate each of their numerical value. For our first example, we have here square root of 9 and square root of 16. So obviously, if we are to write the number line, or let's write it here, so we need to make it longer. If you have here 1, 2, 3, 4, 5. We know for a fact that the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And the square root of 25 is 5. So based on the number line, it is obvious that the square root of 9 is less than the square root of 16. So here's the correct answer. Now, this option is based on the number line. So if you want to try evaluating this in a numerical way by breaking it down or expanding it, so we can have it like this. So you have 3 and 3, and also have 4 and 4. So obviously the square root of 9 again is 3, and the square root of 16 is 4. It's 3 and 4. So obviously 3 is less than 4. Next example, we have here the cube root of 8 blank the cube root of 27. Obviously the numbers here are 8 and 27, and they have the same nth root. So with or without the number line and evaluating this, the cube root of 27 is greater, which means the cube root of 8 is less than the cube root of 27. But of course, let's try to have the number line for this, just for the sake of illustration. Okay, so let's have 1, 2, 3, 4, 5. Now, if we are to have 1 cube, which is 1, so obviously the cube root of 1 is 1. For 2 cube is 8, so the cube root of 8 is 2. Another thing, 3 cubed is 27, so the cube root of 27 is 3. For 4 cubed is 64, and the cube root of 64 is 4. And for 5 cubed is 125, so that means the cube root of 125 is 5. Another thing, if we are going to break this down, so we have cube root of 8. No, this is less than the cube root of 27. So we have here 2 times 2 times 2. Wait, let's change the color for this. Okay, and that's it. 2 is less than 3. For the next example, we have here the square root of 4 blank the cube root of 8. As you can see, we have different nth roots this time. So we have 3 and the invisible 2. So we cannot directly apply the number line or illustration for this. However, we can break this down according to its value. So obviously, square root of 4 is 2, so we could have 2 and 2 here. And on the other hand, we have here the cube root of 8, which is also composed of 2. That means when we are going to extract the value inside the square root here, we get to have 2 and 2. And on the other side, when we extract the cube root, the value there that is in uniform as well is 2, which means that the answer is equal. So the square root of 4 and the cube root of 8 is just 2. They're equal, they're the same. Another example here with 2 different nth roots. First, we have the square root of 49 blank the cube root of 64. Although it is tempting to write that 49 is greater than 64, however, we need to take notice of the nth roots then and again. So this will be your code to evaluate first before identifying if it is greater than, less than, or equal to one another. So based on this, the square root of 49, so if we're going to break this down, we have 7 and 7. Also for the cube root, we have 4 and 4 and 4. So based on this, if you are to extract, the square root of 49 is 7, and the cube root of 64, if you're going to extract, the uniform number inside is 4. So obviously, the square root of 49 is greater than the cube root of 64. This time, as you can see, both numbers are in square root, obviously, the invisible 2. Let me get rid of that. However, 20 and 19, both numbers are not perfect squares. So, obviously, if you are going to have the number line, okay, we know for a fact that 3, 4, 5, so we have here square root of 3, 3 squared is 9, so square root of 9. That means we have numbers in between them. So we have this square root of 10, square root of 11, square root of 12, square root of 13. Wait, let's move this one. Square root of 14, square root of 15, and square root of 16, which is equal to 4. Now let's add this. Let's make this longer. So that means next to the square root of 16 would be square root of 17. Square root of 18. Square root of 19. Square root of 20. Let's proceed until 25. Square root of 21. Square root of 22. Square root of 23. Square root of 24. And square root of 25. Based on this, we could see that if you are going to have this in the number line, square root of 19 is obviously less than the square root of 20. So it's not actually an issue since both of them are in square roots. So that means 20, the square root of 20 is greater than the square root of 19. Next example, we have here two numbers with different nth roots. We have cube root and square root. Anyway, both numbers are in perfect cubed and in perfect square. So we could just evaluate this one numerically. So we have this, the cube root of. So when it comes to 343, we could use 7 to this one. So 7 times 7 blank, and square root of 81 is 9 times 9. So based on this in uniform, when we extract the square root of 343, the number that is in uniform inside this, the cube root sign or the radical sign, is 7. So we write 7 blank, and the square root of 9, of course, 81, and the number that is inside is 9, so you write it down. So obviously, based on the given, 7 is less than 9. In this example, we have the square root of 15 blank, the cube root of 27. We know for a fact that 27 is a perfect cube. However, 15 here on the left side is not a perfect square. However, we could still find its estimate value, or we can cling on going back to the number line. We need to remember, first let's have the square root of 15 here. We know that 3 squared is 9, so the square root of 9 is 3, and then we have square root of 10, square root of 11, square root of 12, square root of 15, which is the given, and the square root of 16, which is 4. Again, this is under square root. Now, we have here that in the cube root of 27, regardless if we break this down or we try to apply illustration using the number line, it's your choice to do. But since we know that 27 is a perfect cube, we could just break this down. Again, we know for a fact that the the square root of 15, let's write this down again, has a value of 3 point something. Let's just put it that way. Compared to this, we have the cube root of 27. So if we break this down, we have 3 times 3 times 3. So obviously, 3 point something, no matter how big or small that something is, compared to 3, is greater than 3. Another example. So both numbers are actually in perfect square and perfect cube. So since they have different nth roots, so let's just try to have this numerically. So for the square root of 100, this can be broken down into 10 times 10. And then here in the cube root for 216, it's 6 times 6 times 6. So obviously the number here on the left side is in uniform, so this would be 10, and then on the other side is 6. So that means 10 is greater than 6, or the square root of 100 is greater than the cube root of 216. Last example for this lesson, we have the square root of 50 blank, the cube root of 343. So earlier, we already know that the value of the cube root of 343 is 7. So we just need to know on the estimation of the square root of 50. So square root of 50. Now, let us try to find numbers or perfect squares before and after 50. So obviously those numbers would be 49 and 64. But since this is just 50, so let's just cater one number after 49, which is 50. Oops. Let's have this on top. Okay, we have this 49, 64. So, oops. Obviously, the square root of 49 is 7, and the square root of 64 is 8. So that means square root of 50 is 7 point something because it is in between 7 and 8. So obviously, if the square root of 50 is 7 point something, that means it is greater than 7. So again, the square root of 50 is greater than the cube root of 343. And that's it for today.